Hey guys, I think they did number 1 or 21 incorrectly, so I'm going to explain why real quick. So, on the initial height, we have it at 125 feet, and we're looking for the height after the 6th bounce. So, let's set up a sequence here. We have 125. That is our A1. So, after the first bounce, so this will be the first bounce height. First bounce height. First bounce height, we multiply by whatever our R is. In this case, 4/5. It's going to be 4/5 of the previous height. So 4/5 of 125 would be 100. And then we have our second bounce. So this is A2. This is going to be A3, second bounce height. And that's going to be 4/5 of 100, which is going to be 80. And then this is going to be A4, or third bounce. This is going to be fourth bounce, or A5, fifth. Let's move this over. Fifth bounce, or A6, and then we have our sixth bounce. Sixth bounce height, which is going to be A7, hence A7. So, 4/5 of 80 is going to be 64. So, 0.8 times 80, 64, then 0.8 times 64, it's going to be 51.2, 51.2. That's going to be after the fourth bounce. And then after the fifth bounce, it's going to be 40.96. And then after the sixth bounce, it's going to be 32.768 feet. Hence, that would be our answer. So if we put this into an equation like we have, our A of 7 would be where we're going to, which would be our initial times 4/5 to the 7 minus 1. 4/5, 6 bounces, which is going to be 32.768 feet. So I believe that's the case. So we have our initial, first bounce, second bounce, third bounce, fourth bounce, fifth bounce, sixth bounce. That's how high it would be on the sixth bounce. Makes sense. So there's our A7 comes from. Okay.